So I want you to think about a circuit where you had a voltage source which was connected in parallel with some resistor, and this is then connected up to some circuit. So from the perspective of the rest of the circuit, kind of looking in the behavior of this source and resistor network, as observed by the rest of the circuit, what does the rest of the circuit actually see in this case? Well, we would observe a voltage across here. And the voltage that we would observe is obviously Vs. That's what an ideal voltage source does. So we can look at this and we can actually notice something interesting, which is that the voltage at these nodes, or between these nodes, is independent of the resistance, independent of R. It actually doesn't matter what that resistance is. It can be 10 ohms, 100 ohms, it doesn't matter. The voltage Vs is always going to be the voltage that is experienced across those two terminals. So you can simplify this circuit, right? If you're trying to solve for some behavior in this right-hand side, in this circuit that this is connected to, then you can just ignore that resistor, right? It actually has no impact whatsoever. And we can just simplify this into a single voltage source, which will have the exact same behavior of creating a voltage Vs across its terminals. So if you see this pattern, and you don't care about the power that's dissipated in this resistor R, and you don't care about the current that's flowing through the resistor R, you can actually just delete it from your circuit. Now there's another similar scenario to consider, which is where you have a current source which is connected in series with a resistor. So IS, current source, resistor R, and I ask you the question of, well, what is the current that's going to flow out of this terminal here? And it should be fairly obvious to you that the current that exits here is clearly IS by the current source. That's what an ideal current source does. So here, the current leaving this network is independent of R, which means that if I don't care about the power that is dissipated in this resistor, if the problem is not asking me anything about that resistor, I can actually simplify this circuit and delete the resistor because it has no impact. So I will have current IS all on its own. And again, this is a completely equivalent circuit from the perspective of whatever it's connected to. So we imagine that this kind of connects to some sort of box out here which has got some dynamics inside of it. From the perspective of this right-hand side, this black box that we're plugging it into, these two circuits are exactly equivalent, and the presence of that series resistor R has no impact whatsoever. And you should be able to recognize that. It's just the behavior of a current source is it will always force that amount of current to flow. So this is another kind of source pattern that is useful to recognize in order that you can simplify these circuits when you see them.